So here, I want us to find out the ratio firstly of tk plus 1 to tk for the expansion of this, and it's going to lead on to us finding the greatest coefficient. So firstly, remember, just use the equation for this, all right? Don't go through that whole thing. So n will just be 9, and b, because we're just considering the coefficient, that's just 1, right? And a is 1 as well. So you have 9 minus k plus 1 on k times that. Simplifying that, 9 plus 1 just becomes 10, and 1 on 1 is 1, so it just simplifies to 10 minus k on k. Good. So we found the ratio, and the next thing we want to do is solve it for greater than 1. So that's just 10 minus k on k greater than 1. So multiply that k up, okay? And then add k to the other side. 10 is greater than 2k. Divide both sides by 2. So therefore k less than 5 is when this is greater than 1. And we're going to be working with that now to find the greatest coefficient. So we know that this ratio greater than 1 is true for k is less than 5, okay? So considering what I've done, just multiply that tk up. So you know that tk plus 1 is greater than tk for 1, 2, 3, and 4, yeah? But definitely not 5, because you can see it's less than 5 here. Now, substituting that in, so for 1, you know that T2 is bigger than T1. Substituting in 2, you get T3 is greater than T2, so on until you get T5 is greater than T4 there, yeah? So that's just substitution. Now, the big difference between this question and the question before was in the question before, we had that number at 2.75, which wasn't a whole number, so we could just consider number on either side of it. Whereas because 5 itself is a whole number, we can't only consider a number on either side of it, but we have to consider that number as well when we consider greater than, yeah? So therefore, we have 2 scenarios here instead of 1. So we actually have tk is less than tk plus 1, and later on we're going to have tk is greater than tk plus 1. But here we have tk equals to tk plus 1, yeah? And that's for when we have k equals to 5, all right? So for k equals to 5, that just means that substituting that in, that's T5, that's T6. So therefore T5 and T6, those two terms are actually exactly the same, yeah? Can you see how we have to have this because we have to include that 5 here in our calculations? Now, for this section, when we have tk is greater than tk plus 1, this is when we have k is greater than 5. So in this case, that's going to be 6, 7, 8, and 9, right? Now, substituting that in, T6 greater than T7, T7 greater than T8, so on. Now, when we consider all of this together, you can see there's a big difference here, whereas we have this T5 equals to T6 in the middle. So therefore, T5 and T6 are both the greatest coefficients. Can you see that? They're both greater than the numbers on either side. So therefore, to find the greatest coefficient, you can just work out one of them, and because they're equal to each other, that's going to give you the greatest coefficient. So let's work that out. So with T5, we know that k is going to equal to 4 in that case, right? So then using k equals to 4, let's work this out. So we have 9c4. But luckily for us, since both the coefficients are 1 and 1, there really isn't that much point considering what the power is to that. So we can just write 9c4. Calculator gives you 126. And just, you know, it's always a good idea to double check. And the best way to double check for this is have a look at T6 as well. And that equals to T5 plus 1, so k equals to 5. So it's 9c5. Put that into your calculator and you get 126. See, they're both the same. and both of these are going to be the greatest coefficient for the expansion of this. So the main point I want you to take away from this question is that when you have k is less than or greater than a whole number like that, there's an additional scenario you need to consider, and that's when k equals to that whole number there, all right? And then you're going to have two coefficients which are both the largest or greatest coefficient.